start the panel session, it would be nice if you can take a seat, because I am now, we are between you, the closing session, and your way at home. I think that we will do our best to entertain you with the last panel of the day. Before we are starting that, I'd like to introduce the panel. I am Klaus Martini, I am from Deutsche Telekom. I am with NGMN in some way and also with the ETSI ISG NFE. It is a pleasure for me to organize the panel and have so great panelists on the panel. It's Dr. Shilin Lan from Huawei. We have Dr. Markus Mück from Intel. We have, and that is a pleasure, we have one of the customers, I come to that later. It's from Colombia, from EuCNC, is a AlphaSec, and then we have Markus Flink from Nokia. Sorry, Hannu from Nokia on the panel as well. All of these guys are representing one part of the 5G discussion, especially about slicing, because slicing is on the topic, our topic of today. We'd like to discuss it more in detail. But I'd like to give you some introduction on where it's coming from, what are the source of this slicing idea, and what are the current status in our industry, because slicing and 5G is one of the hottest topics in the industry, not only in the research area and a couple of other areas as well. And I think it is the right point in time to talk about that more in detail. That means I'm more than happy that we have the possibility to talk to you about the slicing activity regarding 5G more in detail. But before coming to that, I like to make an observation which I have based on what I saw this morning, and I'm really impressed how many research activities you are doing in the RAN aspect. But to be honest, 5G is more than only RAN. This is a fantastic area to research, to look more about the details, but 5G is also has core, has access, has the service layer included. I think it would be also good to look more about, from the research point of view, more about this domain as well, because otherwise we are not meet the idea of 5G from my point of view. I think that is something what you maybe can take in consideration if you do some research activities in the next couple of months or years. Okay, having said that, okay, it's the 5G document, the 5G initiative is based on a white paper published by NGMN. As I said, I am with NGMN. And we published this white paper in 2015. And maybe you know a lot about NGMN, but NGMN is an industry alliance where operators are driven, mainly operators are driven, contributed by the industry and the research institute as well. There's a good cooperation in that group. And you know that we was founded 10 years ago in order to support the introduction of 4G. 4G is done. We did some optimization here as well, but now we are focusing on 5G. And as I said, this document was published in 5G, and a lot of research institutes and a lot of SDOs are looking about that and have a reference to this white paper. Okay, something. Okay. Okay, that's mentioned the collaboration between NGMN and other SDOs and research institutes. You see a lot of people are contributing to the NGMN. There's a good cooperation amongst NGMN and others. I think that is the strength of NGMN in order to push the 5G idea forward and give some guidance from operator point of view to the industry, what the operators are expecting, of course, based on a deeper discussion with the industry, what should be delivered by 5G. And also this end-to-end discussion is a hot discussion in between the operators. You can imagine that, because the operators are like kids, they have different ideas and different wishes, and sometimes they have to guide them also, and that it happens in NGMN in a perfect manner. Okay, that is a white paper, as I mentioned already, that are delivered in 2015, delivered by the operators, and it gives really a clear view how the operators are seeing that from end to end. And slicing, the slicing is mentioned there, and all the activities we were doing today is based on this white paper, based on the slicing paragraph in this white paper. And to be honest, my background is more or less operations and also standardization. And I had a discussion with my colleagues about the slicing idea. And I mentioned them, by the hell, you know what you are doing there, because we are creating a complex vehicle. And that means we have to simplify the idea in some way. And that is the biggest challenge, to simplify the simplification of 5G, of slicing, from an operator point of view, from an operations point of view, let me say. And that is the deeper discussion which definitely has to be take care in this group and in other groups as well. Okay, what does it mean, slicing? We are touching different areas of the industry. It's new business opportunities. We will talk about that more later. What does it mean, business opportunities? And new kits coming on the block. That means verticals I mentioned, the slicing idea. What does it mean? What is a vertical? What are the requirements based from on a vertical? Then you can imagine if you're doing slicing, or we're doing, I think it's much better. If you're doing, there's also a slice. Okay. If you're doing slicing, and 5G is based on virtualization, it has an impact on the organization as well. Processor will be touch, and I think we need new skills in the organization to support 5G, and slicing is more NT and IT coming together. In reality, we talk about it since a couple of years now, but now it should happen that we have a cooperation or a merging between NT and IT in the organization themselves. Then definitely we have some technology changes. We're talking about real-time capability. What does it mean? We're talking about low latency stuff. 1 millisecond is mentioned in the white paper as well. 1 millisecond is a challenge. In some way it will be happen, and what happens now is we've moved everything from the edge to the core, and now we move it back from the core to the edge. And I think that should be discussed more in detail. What does it mean? And of course, I mentioned that already, the complexity of the network will be increased based on virtualization and then slicing, and we have really a complex network which should be managed in a proper way, cost efficiently, from a customer point, with a high quality and good reliability. I think that is something what should be discussed in detail, and that is what I like to give to Hans here. Please don't think only about the RAN aspect. Think about the complete network which we are creating, and what kind of thing has to be done to make it to do it in a proper way, that everything is aligned to each other. Okay, I think these three aspects that we will discuss in the panel today. We have good representation for each of them. And I think it's a good chance, and I hope that you have an interactive panel, means have a couple of questions which we can give answer to, and that would be a perfect game which we can play today. Okay, why is 5G and slicing so important and interesting? You see on the left side all these different kind of technologies we are mentioned here. Is Wi-Fi, is smart logistic, and we saw this health presentation this morning in this room. There's also one aspect in 5G. We have smart factoring, all of kind of thing. This flexibility is requested, and we have to do that in a right manner. If we would do that on the current technology and the current networks, I think we would be failed. It would be not flexible enough. It will be not easy enough. It will be really cost intensive to manage this kind of networks based on the old way how we did it. And that is the reason why we said, okay, we need a new technology for 5G, and one aspect, as I already said, is a slicing aspect inside. It's this white picture is based on it's mentioned in the NGMN white paper. You see all these kind of levels in between, and it gives more structure about the new network, how we structure it, how we organize it, how we increase or decrease the complexity, and to implement it cost efficiently. I think that is something what is the basis for the idea which we discussed in the NGM white paper deeply. Okay, but now the devil is out of the box. The slicing is out of the box. Now we have to manage the devil. And This is also more a little in detail, gives you an idea that we have the infrastructure as a service idea, that we have the platform as a service, and finally network as a service as well. And all these different 3 layers have to be organized in a good manner, and the slicing is, a slice could be run across all these layers. That is a possibility. But to be honest, a lot of organizations discussing slicing and from different point of view, and the understanding what is a slice is really not clear. Everybody has a different understanding what a slice is from end-to-end point of view. Is it only access? Will it touch all layers or not? I think this kind of discussion should be more synchronized and more organized, that we finally have the same impression and same definition what a slice is and what it means and what it's standing for. I think that's a bit controversial situation for the time being, which we have in the industry. Good, that is a short introduction about the slicing, how the status is today. And before we come in now to discussion of each of these, I like to have some general questions to my panelists. Of course, feel free to raise your questions as well. If you have a question, you can do it now, or you can do it by the end of the general session. Okay, then I have a question to my panelist. What do you think is the difference between the slicing concept and the old traditional way how we manage services, for example? What is new in slicing? How is your interpretation? Celine, what do you mean about that? Yeah, no, and you have to give, or Markus, can you explain what is your view of the difference between
yeah, so does this work? Yeah, I believe it works. So I will basically comment on this also in my presentation. I believe that it is actually useful to go one step up. I mean, what is actually really the groundbreaking new aspect? And I believe the groundbreaking new aspect is the virtualization and softwareization of the entire ecosystem. And I believe that the slicing is basically a logical consequence of this, right? So it's a logical consequence to exploit the new flexibility of the network, to take the different building blocks and construct a kind of optimized subnetwork for each of the various applications. So I believe the main difference, just to answer this question directly, is actually this possibility to take the different Lego blocks, so to say, and to combine the Lego blocks for each of the in particular vertical applications in a way that is optimum for the respective target applications. Like the combination of Lego blocks will clearly be different for automotive communications, will clearly be different for high reliable, low latency health applications, etc. So, and this is actually the main difference. So the intelligent combination of components for a target application. Thank you.
Okay, thank you. Then Hanuni, there should be a second mic as well. So give that over. Here's another one.
Thank you. I think the biggest thing in introducing slicing is that it changes the focus from connectivity-centric business models to service-centric business models. It enables, because it's a tool for multi-tenancy, it enables operators to reach verticals. And this is where we think that is the bulk of the opportunities and the rationale for 5G networks.
I have an additional question for you. You mentioned
Yes.
the business model and the service model.
Yes.
Do you expect there will be a change in the business model and in the service model, or?
Well, it enables new types of, there will be the existing operator model where we package connectivity and all the existing telecom services, packaging, tariffing, and so forth, will remain there. But then when we want to reach new actors, extend from the basic telecom industry to adjacent industries, that's where slicing gives means and tools. Tools in terms of how we manage the network, how we share the common resources, and also provides for the verticals means for controlling their own connectivity and computing needs.
Okay, thank you. Do you like something to add, Ashwini?
Yes. So basically, I want to emphasize here, network slicing itself is not a single technology. So it is a set of technology make it possible. So I remember in 2014 is when the network slicing concept appeared, emerging in this 5G context. And then people begin to discuss, like, what is network slicing? Is this a new term? Is this a business term? Or is this a technology term? And then, yeah, it was not clear at the beginning, but then after 2014 and 16, and it is slowly coming even to the standardization, and it become more clear. So basically, if we think, what is network slicing? Some of my colleagues, like yesterday, we even discussed, is this Planet? Like it's used like 6-7 years ago. And people already use a virtualization method to slice the network to do experimental for the university testing purpose. So is this the same as what we are talking in 5G? So my answer is no, because this could be part of it, but it's not the complete picture for that.
Okay, thank you. Then maybe from a customer point of view, some comments.
So in our point of view, and not addressing technological aspects, I just expect that slicing will be something that provides me the service that I want or that I expect with a lot of flexibility and at a cost competitive without the need for a team of experts, of technological experts to configure, to deal every day with keeping the communications, the processing and so on. So basically that is the way I see it. However, as I will address in my presentation, it is not clear by now what is or what will be in fact a slice. What are the interfaces, the frontier? So probably that is necessary to be more clarified, not so much from the technical point of view, but from the user, the customer point of view.
Okay, thank you. Before I have a final question for the panel, any question from the audience for us? Here's one. To be honest, it's the first time that I see that somebody moving a mic in this way. It's a completely new experience. It's done. Okay.
Okay, yeah, it's a very simple question. So this slicing, so will it, as expected, would generate new market segments? That means will it like bring additional revenue? So how the operators will see this average revenue per user? How will it be affected?
I think the question about the revenue per user from an operator point of view, I think that it's not I can't give you a clear answer about that because the business model for the operator is under discussion. I think we had this business model discussion before, and it will be changed, not only for operators, it will be changed for the complete industry. And that it's, of course, we are expecting, as I'm talking on behalf of Deutsche Telekom, that at least the revenue will be not decrease, and that no business opportunity, whatever does it mean, of course, that is in the scope of what we are doing.
Right, what I'm saying is, so if for example, will this bring new actors into this operator environment, like small operators, or catering for each of these kind of specific slices, like low latency or etc. So will that affect the existing operator environment?
I think yes, it will be in some way. It will be definitely this business opportunities for the small operators, and of course, it will be impacting the bigger operators as well. It will be an impact. Okay.
Wow, caught it. So slicing, yes, very interesting. And if you're talking about a virtualized software infrastructure, very clear to understand what we mean. Let's ask the difficult question. What does this mean when I have finite physical resources, as in the real world in the RAN? What happens when I have a finite air interface, a finite resource in terms of computing, a finite resource on what I can actually transmit? How do I handle that then?
Okay, who would like to give an answer about that? Because I have a panel, I have to not to work, I have to organize a panel.
Maybe just a quick question from my side. I think we have a perfect optimization problem, right? We have an optimization problem to meet certain requirements among the different target users among the different verticals, and we have constraints to this optimization problem, right? And so we need to find the optimum working point. That's basically it. And if we cannot find a working point that satisfies the user, well, we have the possibility to add more resources to our system, or to try to renegotiate the service level agreement, I believe. I think that's as simple as that.
I think this question actually perfect fits my previous comments, like network slicing is a set of technology. And when you try to look into the different technical domain, actually they may have totally different methods in terms of slicing. And if you want to know more details, I will address it in my presentation.
Okay, I think, thank you for this couple of questions. I have a couple of more. Maybe I have time to talk about detail, but in all the time, I like to, of course, give the possibility to my panelists to present their topic. At first, I invite the customer. Who knows what a customer is from you guys? Please raise your hand. Not your private customer, the customer based from the industry point, because you are researchers. Nobody researching don't care about customers, to be honest. Okay, but now we have a real customer here. Of course, it would be a pleasure to get the customer view about slicing and 5G. Please come on stage. This is classical technology. Ah, not here, not here. Okay, thank you.
So good morning to everybody. I'm coming from a company named Defasec in Portugal. We are partner of second phase 5G PPP project SliceNet. And I will try to give an answer to some of the questions that have been raised. In fact, I may be a customer, but here today I'm in the job of representing a company that provides turnkey solutions to the main group of utilities, being them namely energy, environment and industry, or mobility and transportation. So in energy we have technology products, smart grids, SCADA systems, and so on. On the environment we provide turnkey solutions customized to the customer. More and more they are looking for using the telecom service for the telecommunications support layer. At the third sector, a similar trend is happening on transportation. We provide turnkey solutions for light railway metros, for example. Usually, we build their own network for this. However, more and more, there is a trend to use the service operator, someone that provides the capability, the service to transmit the different signals or the different information, of course, fulfilling the different requirements. So before going in detail, I would just say talk about trends. Shift is happening even in verticals, even in traditional utility companies. And verticals are moving more to on-demand digital access economy. So more and more, their business is also data-driven, is also supported on managing data and doing interaction and communicating. In another sense, we are, all of us, but the similar aspect happens on the business. There is the new B. That is like the job is never ended. We buy a mobile phone and it is regularly updated. We buy or we install an equipment and regularly it is necessary to put there some new version of software. So this is a trend. This requires flexibility. This requires connectivity. This requires the capability to being updated, to being at least for, that's the way we receive the info, for security purposes, or for privacy, or for protection. In another way, the pace of innovation is accelerating, is growing from day to day. And this innovation comes a lot from R&D, from research, but much more, or even more, nowadays, it comes also from combining different technologies, different knowledge, different perspectives. Once again, this looks for flexibility, for capability to combine in different moments, different providers, different technologies. So I would say that everything is becoming connected and providing data, coming from sensoring, coming from meterings, coming from interaction of the final customer that wants to be demanding new functionalities, that wants to interact. This new data-driven business requires more and more specific, secure, So, it's not helping. Because here he was moving.
No, it's not moving on this one. It's not moving on the
I don't know. I don't know why. Probably it should be.
It's changing here, but not there.
Probably the slicing is not
Stable enough.
managing.
Do we have another cable? What you are doing, and if Microsoft is not working, you are restarting. I think that is a normal thing what we have to do here now. To restart, and well, maybe the problem is solved, maybe not, I don't know.
It is not there.
I think that is it's a physical problem, not a software problem. It's a cable problem, I assume.
But it is not there. Yes, but now
Okay.
when I do, okay, now it is there.
Perfect. Thank you. Thank you for your help.
Okay. So I'm sorry because over here I was seeing things happening and I was not considering that. So in any case, I already went through this and I was just commenting that this new data-driven business requires more and more secure, on-demand, high flexibility ICT capabilities at a competitive cost. And I would say that the first challenge or first question is, will 5G slicing attend to those expectations? Of course, those expectations will change from vertical to vertical, and probably they will continue evolving on time. If so, that is a big challenge for operators, for 5G providers, but it will certainly be a huge opportunity. It was already mentioned, for myself, I still do not know exactly what will be the frontiers of a slice. Will it be more traditionally only associated with networking? It will join also processing, storage, may I, as a customer, fine-tune what I'm interested on? Because certainly, and more, as I mentioned before, business are more and more data-driven. May I be comfortable to send or to share all my data that is specific from my business? I would say those are the main or general questions to be addressed, and to start putting confidence on the verticals. Over here I have a large set of, I would say, requirements that at the same time we could consider as challenge to 5G slicing. Some of them, they require functionally safe, very high availability and reliability, end-to-end extreme reduced latency. And this applies mainly on health, railways, specific applications of railways, autonomous driving, energy sectors, and so on. Then we may have another kind of slice for high volume real-time mobile data, for mobile health, or for mobile high-definition video, for automotive, for railways. On the other side, we certainly find verticals that require low latency, hotspot, machine-to-machine communications, industry or factories of the future. For example, we may also have, and we have certainly requirements for high-volume media service with ultra-dense hotspots and static or low mobility environments for sport events or multimedia festivals and so on. So I could continue on this. Eventually, one or another, adaptable, high capacity, quality of experience, low delay and low cost of deployment. In this case, for media and entertainment events, for emerging interactive service supported on augmented reality or virtual reality, and so on. I would say that last but not least, because I consider it is transversal, what about security, data privacy, dynamic on-time service creation and release? Of course, all of this at the cost competitive, because nowadays verticals are more and more required to be competitive. I will now just try to drill down a quite known and use case or business case related with energy. Before, energy companies would be mainly structured in 3 or 4 main areas. Some central point, we would have generation of energy, then we would have transmission, then we would have distribution, and then consumption on our house, on our industries. This was like a conservative, static, unidirectional grid. Not any, I would say, flow of information on the other direction, only money to pay the bill. That was the main concept. Usually they consider longevities for their investment around 20, even more years. They deploy and operate forever. That was the concept. They over-dimension their infrastructures to accommodate future demand. And usually, those main utilities, they want to have, and they have still their own telecom infrastructure, their own ICT, I would say, storage, processing, and so on. However, there is a big underway change that is happening. So we are moving to a quite different ecosystem. On the center, on the red points, we may see advanced metering infrastructure. We may see demand-side management, try to set up the level of energy that I have available at each moment to the consumption. We have the electrification of transports with electrical vehicles, distributed generation all over the place, and more distributed storage. I would say customer becomes the center of the system, of the ecosystem. What are the main challenges? In some use case or some specific applications, energy ecosystems want end-to-end latencies below 1 millisecond, namely for grid protection and control as micro grid operations. Cybersecurity and data integrity is a must. It's quite relevant. Availability and reliability too high. Of course, always a cost competitive and built toward a service oriented. So I would say in this specific area it's quite important to build confidence with the energy community in order to discuss and to understand that there is no problem in sharing their critical data. What are the applications, the opportunities? They are a lot. On sensoring, on smart metering, on forecast energy production, on demand response, load shifts, storage control, voltage regulator, microgrid market interaction, and many other services that certainly will come in the future. I just scratched there on that map some of the main requirements that have been discussed within 5G. So we may see that from case to case or from application to application, they change a lot. Just to end, I will just leave a few very broad recommendations. First, the range of requirements from verticals is broad and are not straightforward, some of them. It is essential a close collaboration with verticals to understand key features of each business and understand well on the future trends on their expectations. Cybersecurity is very critical, and also data integrity and privacy. During those days, I honestly do not saw too much about cybersecurity. I was expecting, because nowadays more and more of us and companies are aware about this aspect. I don't know if the 5G community and the regulation entities could not consider some trade-off in order to increase what they manage or what they can do in this area of cybersecurity. Slice should be fully service-oriented and really easy to start in order that make easy life of the verticals. Building confidence with verticals, in my point of view, has to be built since the beginning. So nowadays, it should be starting. Probably some of them should be involved on some standardization that, in my point of view, is quite important and relevant. Also because more and more the utilities, namely energy or water or gas and so on, they have also to interact more with utilities in other countries. So regulation should probably go behind only the technological aspects of 5G technology and so on, and include also some of the utility requirements or needs and so on. Thank you very much for your time.
Okay, thank you for your great talk. Some immediate question from the audience for a real customer. Okay. I have one for you, not moving, please. I have a question. You mentioned a couple of different requirements or recommendations, what you see from a power company. And do you think that we have thousands of different slicing based on different capabilities, low latency or high availability, this kind of stuff? Or do you expecting that we are delivering only a couple of different slices?
Okay. So, as I showed in one of my transparencies, at first sight we could consider we would have a broad, large number of slices. However, after analyzing the requirements, we really understand that we may group them in some main sets of slice. Of course, attending different applications or in different vertical markets. However, then I believe there would be a minimum number of slice, I don't know, something between 10 slice that may be probably on demand, just use them. And I don't know, probably to keep the possibility for some verticals to ask for a customized slice, of course paying for that eventually. So we saw that on different applications, while they are very, very different on the base, on the service, on the customer, on the driving, at the end, they have a set of requirements that are common.
Okay, then I have a short question for you. Please give me a short answer. Normally we are talking in slicing and in 5G about virtualization. That means we have software and not talking about hardware, because the assumption is we have standard hardware which we are using in the future. Do you expecting also that you create a slice from your point of view, that you have your own hardware where the slice is implemented, means where the software is implemented? Is that a requirement from your side to an operator or to a third party supplier?
You know, I would say that both cases may or should be previewed. Namely, utilities, they have a legacy. So it may not be easy to develop new equipments with the interface for legacy equipments that nowadays more and more are providing data through sensoring and so on, also for managing and for predictive maintenance and the optimization of the future operation. So to be easy to use, we would have at least most of the possibilities like an app, that I may go there, I select it, I open it, and I just fine-tune a few parameters. But I recognize that in other cases, there may be more engineering in order to set up the slice and so on.
Okay, thank you.
Thank you.
Again, if you have no question now, then I would move to the next presentation. No, Markus, it's your time.
Darkness. So.
You need an engineer here.
Thank you.
Perfect. Thank you so much. So The objective of my short talk here is to, first of all, invite you to take a step back, as I mentioned in the very, very brief question-answer session just earlier, and to really consider that the real disruption and the real innovation, at least in my opinion, lies in the fact that we are going towards massive virtualization and softwareization of the entire ecosystem, right? And so what I want to do today is to give a short overview on how I see network slicing in this context. But I would also like to go basically a step further and provide more questions to you, more questions than answers, because I believe that slicing is basically just a logical consequence of this trend to go towards more virtualization and softwareization. And one question I would like to ask during my presentation is basically, what does that mean besides the network side, which is clearly the focus point of the industry nowadays, but what does that mean also to the terminal side, right? Because I believe the whole slicing discussion is really focusing only on the part of the ecosystem, so mainly on the network, and I think also the role of the mobile device, the terminal or the client device in general, may need to change in this ecosystem. And it would actually be good to have a discussion in this group today in order to see whether there are any opinions on this. So this is basically the statement I just made. So I believe that network slicing is just a part of the trend towards virtualization and softwareization. And as I mentioned before, I believe that the key idea is basically to say that we now have building blocks and building blocks everywhere in the entire network from an end-to-end perspective. So we have building blocks in the core network. So we have, let's say, computational resources we can move. We have access network capabilities. And here, just to give you one idea of what the basic possibilities are, I'm actually participating in a project called 5G Champion. And one question we are asking ourselves is here, wouldn't it be a good idea to actually take parts of the core network in a dynamic way, rather to the access network, wherever needed, in order to reduce latency, right? So this is actually an interesting point. So it basically means this whole aspect of slicing, adapting services to specific applications, etc., is not about reshuffling the building blocks within their respective domains, within the core access or access network or access technology domain, but it's really also cross-domain, right? So the question is, can't we shuffle actually components from one domain to another domain in order to better serve the needs of the client? And then I also believe that one aspect that is quite interesting in this domain is, I mean, we heard this comment before, that this whole virtualization, softwareization approach basically leads to a situation in which probably maintenance is getting to be more simple. So in case that a problem occurs, you don't have to send an expert to the field in order to analyze and resolve the situation. No, you can actually have your virtual environment control framework and take this in order to resolve the problem. But this leads to another opportunity. So this basically means I cannot only resolve problems from a central control perspective. No, I can also dynamically modify the network based on the client's needs. And I think this is also a novelty which we did not have in the past. So basically, if let's say if a high capacity need occurs at short notice at a certain location, I can deal with this high capacity need at very short notice, right? So I can take my central control framework, reallocate the resources, and basically serve the needs of the client not only in a static way, but also in a highly dynamic way. So I think one of the key novelties of this entire framework we are discussing here is the possibility to take into account highly dynamic and time variant configuration of the entire ecosystem. And basically something that I believe is also quite interesting is the left-hand part here. So the left-hand part basically relates to the radio access technology. And I think it would be, or I think it's still quite of a research topic to see how the level of reconfigurability and flexibility in this part can be integrated into the entire slicing and softwareization ecosystem, right? So just take a look at the massive MIMO, just take a look at the combination of multiple radio access technologies, etc. So I think it's still quite an open question to say, you know, for example, if I have lots of antennas out in the field, so sorry, I think I got a little bit far away from the mic. So just take a look at the question, what happens if I have lots of antennas out in the field? Is there some kind of optimum working point of combining all the resources I have, not only on an access network and core network perspective, but really also on the left-hand radio access technology perspective, right? So is there a kind of optimum working point that gives me, let's say, some time-dependent optimum in terms of complexity, power consumption, and usage of resource, right? So let me go one step further. And then I believe, and I think this is quite obvious, but this is just to mention that we basically share, I believe, the views of the field in this domain. When we are looking at the possibility to readapt components of the network, if we are able to move and combine these Lego building blocks I was talking about before in any way, I think it's just natural to say, well, you know, for wireless broadband, for real-time control, for sensors, for videos, whatever, the combination, the optimum combination of these Lego blocks is most likely different for each and every case, right? So I think the challenge is here simply to put together the Lego blocks we are having in the most optimum way to serve these needs. And I think there was the question just before asking, well, probably everything, you know, this vision is nice if we probably have an infinite number of resources. And what happens if the number of resources isn't infinite? And I think this is again a problem statement that is interesting for the research community, I believe. So I would again take the question back. So can you, for example, as the research community split up the components in the network in a kind of, you know, set of components of reasonable granularity, formulate an optimization statement subject to the constraints we just have, so subject to the available level of computational elements, subject to the level of memory resources, subject to the energy budget we have, etc., in order to have in such a multidimensional optimization framework the right solution, the right configuration of the network. I think it's a very beautiful optimization problem for the academic domain. So, and in this, as I mentioned, it's very natural to basically say I take components on all aspects of the network, and here I think this slide beautifully illustrates how things may basically operate in practice. So you have automotive applications where, for example, you have safety-related constraints, where you know, failure of communication may have dramatic consequences. So obviously, the combination of components of your network is different compared to an automotive case, where probably ultra reliable, ultra low latency communication services are required, and then again a different combination of slices may be required. And but I think this is kind of a vision that is quite common in the industry nowadays. So from this point, I would like to move a little bit forward. So I would like to ask the question, in this kind of fully virtualized, fully softwareized ecosystem, what would be the role of future mobile devices, right? And so just take a look at the change of the requirements for these devices. Let's take a look in the automotive case, for example. I mean, in the automotive case, you basically have components that need to be relevant over the lifetime of a vehicle, which is 10, 20, 30 years, right? So this is an order of magnitude more compared to the smartphone case, which we have today, where the typical lifetime is 2 years, right? So the question is basically, what changes? And just to give you one hint, is the need to address vulnerabilities that are coming up during the lifetime of of such an application, of such a vehicle, will be one of the dramatic challenges we need to address. You already know that nowadays it's a challenge to address vulnerability of a smartphone, but still you are able to constantly upgrade it, to even provide new hardware after 2 years. But what happens, over a 10, 20, 30 years time frame? You cannot just upgrade the device. In case that a vulnerability comes up, you cannot just recall all the vehicles into the garage. It will take forever. You need to address these aspects immediately. And so my conclusion is that we will need to take this idea of virtualization and softwareization not only to the network, but also to the client side. And I believe the industry at this point in time is still focusing on the network, which is right, because certainly these are the most challenging and urgent questions to resolve. But at some point in time, we will need to ask ourselves the question how to take this to the device side, and I hope actually that we will have also ideas and solutions from the academic side on how to resolve this. Just to tell you, we started in EuCNC to address this kind of virtualization, softwareization from the client side. We have come up with a kind of new architecture that allows the abstract representation of client-side radio components. We believe that we have gone one step into this direction, but we still need to address the question, on like how exactly flexibility needs to be handled, because obviously in the device, power consumption, lack of resources, etc., is something that is much more difficult to handle compared to the network side. At the network, you can always add additional resources on top, and the client, it's more difficult. So basically, to summarize, I would like to leave you with the question and challenge for the future, how to exploit actually the massive processing power we have in the best way. And I think slicing is just one way of exploiting that, and I'm sure that we will come up with further ways on how to serve our customers in the best possible way. So thank you very much.
Thank you for that. Some question for Markus. Okay, you can assume that I have one.
Yeah, everything seems to be clear. That's good.
Not for me. I think I found this approach very, very interesting. We have these different domains and we are looking about.
Yeah.
My question is, you mentioned also the devices. Is a
Yeah.
device part of a slice, yes or no? Or depends?
Yeah, I mean, the device is certainly part of the end-to-end ecosystem, right? Because you will need to take the service from the network to the device. If you don't, or to the client, let's say, let's call it client. So it's certainly part of the ecosystem. I think in today's thinking, we are not really addressing the adaptation of the client, in the same way as we are addressing the adaptation of the ecosystem. So I think we are currently thinking of the client as being static in some way and unchangeable, unmodified. And I think this is the point where we probably will need to think again once the industry has moved forward in addressing slicing purely on the network side, I believe.
You expecting more flexibility requested by the client?
I definitely expect more flexibility because, just to take it from a very simplistic angle, would it make sense to have the entire network fully virtualized, fully softwareized, and the client still remaining, let's say, static, being implemented in a kind of ASIC, highly optimized way? Does this really fit together? I would really question that.
Okay, thank you for that. Last question for him? Okay, that's one. Okay, or
You
maybe
need to
he
catch
will
the box. This
catch
is the
the
challenge.
box. Fantastic. Okay, done.
Thank you very much. I would like to come back to the security question and the necessary upgrades or updates that today are basically common practice.
Yeah.
Now, assuming that some of the equipment in the verticals will become attached or part, even in this case, of the 5G future infrastructure, how do we actually really handle this security vulnerability discovery? Do we expect, for example, that a tool cutting machine that has a lifetime of 20, maybe 30 years and is attached to the network receives updates, security updates every couple of months or maybe weeks? Or the door lock, for example, in a building which is also attached to the network has basically the same problem. Now the building lifetime is, 50, 70, 80 years or more.
Yeah.
Or the cars, typically, 6 maybe to 10 years.
Yeah.
It's a very open question, right? How do we handle that?
Very open question. And I think it really depends on the use case. So if you have, let's say, an industrial machine, like a cutting machine, right, that is in a closed, maybe secured environment, the potential of security attacks may still be there, but it's probably not so relevant. But if you have
the car,
but the car, exactly. So if you have something like cars, which is on the market, which is available at that scale, and with that kind of impact in case that you have a security threat, right? So I think the problem definitely needs to be resolved. As you mentioned, we are using currently firmware upgrades on our smartphones, and I think the question certainly is this still the right way to go for this new application? Do we need to do it differently? And I think it's still a very open question, yeah.
Yeah, well, I would like to challenge that one because today we see that most manufacturers of devices, smartphones for example, drop support for older devices like after 3, maybe 4 years.
Yeah.
So I don't know, a 3G, what is it, 3GS iPhone is, long ago, not anymore updated with software and things like that. The same applies for the first, second generation Android stuff. So these things are gone basically.
Yeah.
But their lifetime was already planned to be, 3, 4 years.
Exactly.
But my car is not planned to be only 3
Exactly.
years.
And maybe let me just comment on this a bit further. Probably not.
Please a short answer.
But very short. Just to tell you, the European Commission is currently in the phase of addressing Articles 3.3i and 4 of the so-called Radio Equipment Directive, which is a new directive and will deal with radio reconfiguration. And there is going to be an expert group that is going to be set up on a European Commission dealing with the implementation of these articles. And I believe these are typically the questions that we will exactly need to answer in the phase of implementing this kind of new regulation framework. So thank you.
Okay, thank you. I'll give him applause again. Okay, in order to moving on, we're coming to the next presentation. It's Julian from Huawei.
I have to say, 10 minutes to talk about the overall system design for network slicing is very challenging. So let me do my best. I think you already heard a lot about the problems, why we need the network slicing, and if we can support the amount of, we are talking about Like, do we have a 10 slice, 100, thousands, or even more? So it's good to hear our first panelist mention like at least they need around like 10 from one customer. But if you think about how many customers we have, so you can imagine the amount of slice we will have in 5G will be big. So I will put my level of presentation a little bit down. So I will really want to talk about how feasible this is to be done from the whole system point of view. So, okay, luckily it works. So this is an overview about what is an end-to-end slice architecture could look like. So the main features here, I put a 2 point here. First is a 3-layer architecture. So first one is a common infrastructure, meaning like being different from the conventional network. You may have a dedicated network for specific verticals, for example. So the idea for slicing is that we want to support the different vertical services and use cases upon the common infrastructure, meaning like they share the access network, transport network, core network, and even the cloud resources. So this is very important for the concept. And the second layer is the network service layer. So basically here is the network slice instance. So here I'm emphasizing instance because network slice, you can think about a higher level concept, but when you really deploy in the network, the terminology we use is a network slice instance. Then this is the logical network actually you use to provide network services for your customers. And as shown, these are just like 2 examples. Like, so different use cases can coexist by using different network slice instance upon the common infrastructure. So this is a really fundamental idea for network slicing. And the third, actually I highlight in this slide is about the network management layer. Because this part tend to be considered not so important in the previous generation networks. But for 5G, this is very important because this could be the whole brain of the network slicing concept. So basically, this network management layer, it will manage the whole life cycle, like how you define your slices, meaning like you have interface towards your verticals, you will negotiate about the requirement, and then you will have the contract done, and then you order your network slice. And then within your network, you will design how this network slice could look like. For example, which network function you want to contain and which type of access you want to have, and so on. And then you will break down this requirement to different domains and instantiate the network slice. So then for the following part, I will really break down to each single domain to talk about how can we do this. So the first one is about the core network. Because network slicing, as Klaus mentioned, like a lot of people think about 5G is only about the access part. So this is not true. Because network slicing is kind of like a concept, it's a system architecture concept. So this part is discussed a lot in the 3GPP SA2, which is responsible for the system architecture design. So I take 3 examples, like if we say we want to have network slice for eMBB, enhanced mobile broadband, and URLC for the ultra-low latency, ultra-high reliability slice, and we can also have like MTC type of slice instance for the like massive MTC. And then basically the main feature for this core network, I can summarize in 3 points, like modularization. So this is also what the legal part Mark was talking about, like you can break down these network functions in smaller part, and according to the requirement from your customers, you can make a customized composition of the core network functions. And the service-oriented. So this is a very interesting part, because in the conventional network from 1, 2, 3, 4, we all have this kind of a reference point idea. Basically, if you want to define the core network, you have to go to the standardization. You have to say, this is a network entity I want to have, and this is the interface. But this may not be suitable for this kind of a breakdown modularization method. If you consider you have a lot of like smaller finer grained network functions, then it will be extremely difficult to standardize the interface. So therefore, that's the reason like the current 5G system architecture working group in 3GPP want to define a more flexible way to construct your network. So this is the idea for this service orientation. And the third, Marcus already also mentioned, cloudification, virtualization, meaning like these network functions can be run as a software and you can locate it anywhere with computing resources. So this is another level of flexibility. Okay, another thing I want to emphasize here, so in the core network, because the network function will appear as a software way, so actually the amount of network slice instance could be business driven. So what does this mean? Like, for example, I can have 3 different slice instances with different type of network function composition. But for example, if I want to support different type of companies, like company A, B, C, and D, they may require the same core network function, but you can still have different instances for them for the business purpose. So compared to the core network, the access network could be quite different. Because if we say the core network is business-driven, we say the access network is performance-driven. So the reason is because the access network has quite different resources. So hardware, software, and you also need to handle frequency. And this is very, very different from the core network features. So in order to understand why this is performance-driven, because if you have exactly the same access network, can you support all the use cases? For example, can you support the eMBB as well as the ultra-low latency? This might be very difficult. So in this case, we may also have some customization designs on the access part. But this design could be multidimensional. For example, you have the frequency results, you have timing space, and you can also have different coding, modulation, and so on. You can even have customized the mic layer, and you can have customized the resource allocation. So therefore, we consider this tailored protocol stack could be one of the major features for this to enable the network slicing on the access part. And the next is about the transport network. So this is also a very interesting domain because for the people who work in the standardization field, especially, 3GPP, they do not really consider about the transport because in the 4G system, everything is IP. So when they try to standardize, they standardize network functions. They do not standardize the transport. But if you talk to people working in the transport network, they say, hey, we already have network slicing. We have a VPN, right? So it's already kind of like a slice my resources in the transport network. So, what more can you do on the transport? So actually, this is also not true, because for the transport itself, it has a very unique feature. So what we call is a fusion of multiple technologies. So basically, transport itself, it can have different technical domain. Like you can have the part which is optical enabled. You can also have the part which is optical enabled. For example, you can also have different like really physical layer technologies for different domains. So transport network itself is kind of like a fusion of really different technologies. And for each technology, they may have different ways to support network slicing. But in general, we can classify it as like a software way or hard way. So the software of slicing is mainly referred to this kind of virtualization technology. Like you can have a virtualized network embedded in your transport network, but this virtualized resource, they could share exactly the same physical resource. But maybe some use cases say, oh, this is not enough for me. I want a higher isolation requirement. Then you say, then we can go to the harder slicing, meaning like you can have dedicated resource like a dedicated core, or you can even have dedicated port or pipe. So this is called the hard slicing. About terminals, so I think maybe this one can answer some questions from Marcus. So we also have some thoughts about terminals because you know Huawei, we also produce smartphones. And we think a lot on the network side, how can we do the slicing? Like we really want to push this latency as low as 1 millisecond. But the terminal guys say, hey, if my terminal doesn't support your slicing, and I can easily do some resource scheduling, and then the latency can change to 10 milliseconds or 20 milliseconds. So then all the fancy idea about the slicing of achieve extreme performance doesn't work anymore. So yes, so in this case, probably the terminal also need to support. Then we begin to discuss in which way the terminal should support or can support slicing. So in general, we have 3 models. The first is doesn't support at all. Of course, like the terminal we have for 5G is very diverse. So for example, we can have really low cost terminal like sensors, right? If a sensor itself is they have an energy constraint and then they do not have a lot of computing capability, then you cannot expect the sensors to have this kind of fancy feature to support multiple slices. So maybe for such devices, they can, when they power on, they only access to 1 slice, that's all. And the second is vertical. So vertical way is like you try to rely on your hardware and operating system capability. So maybe you want to support it for one device, you want to access it to different type of slices, then you can design different hardware and software in order to capture this kind of customized features. So this is what we call is vertical. And the third is about horizontal. Horizontal meaning like actually we really rely on this capability from my hardware and also operating system. So in order to let my applications, even applications itself can be aware of different slices. So for example, if I have an application which I can send a message, but meanwhile they can also be used for bank transfer. So maybe one application itself can even want to use different type of slices. So in the end, I want to put all this together because yesterday we had a really good panel about the V2X. So I think maybe this could give you some idea about how to like use this kind of network slicing for our vertical customers. So as the first panelist mentioned, like even for one customer, they do not imagine like they only use one type of slices. So I use this automotive industry example, like if one service provider want to provide their automotive services for their terminal, like a car, and then they may say, okay, I want to let my car to support automatic drive. I also want to provide this kind of high definition map in order to assist the driving if the user want to still drive, but in a more comfortable way. Or I also want to provide services for the passengers in the car. Like if you drive a car for holiday, you have kids, you want them to watch some videos. So actually the type of services happened in one terminal already is very diverse. So therefore we can imagine like for one customer, we can really provide a different type of slice and then bundle them together, offer them as the network services. So that according to the different features of the services, for example, if I say I want to do the automatic drive, meaning like I have a really high requirement, then I may have a specific design on my run part to achieve ultra low latency, and then I push all my core network functions to the edge, okay? And then if I want to provide the other two, like high definition map or video streaming, then I do not have the specific requirement on the run part, but I may have different requirement on the core network. For example, if I only want to like push certain information to the user, I may not need mobility support. So this is like one very simple example. So all these combinations can provide the customers to have their services provided to their customer or end user and with the best efficient way. Yes, this is a summarize. Okay, perfect. So I talk all these feasibilities, how to do this network slicing in different domains, but still it doesn't make it end-to-end. So I use my first, maybe you cannot see clear, but this is just the first 3-layer architecture I show on the first slide, and try to map it in different standardization bodies. So as you can see, currently 3GPP is one of the most active one, but about the access network and the core network, it's covered by 3GPP Run 2, Run 3, and the system architecture covered by 3GPP SA2, security SA3, and there are also BFF to talk about the fixed mobile convergence. And then also we have GSMA where we discuss about how to define this slicing template And we have 3GPP-SA5 to discuss how should we do this slicing management, like in the network management part. And of course, EuCNC for the network function virtualization, and we also have the IETF for the transport network. So as you can see, this is one architecture, but covered by almost 10 standardization bodies, SDOs. And then in order to make this really end-to-end, so actually I think technology might be not the worst part, because we have solutions. But maybe the most important thing is how to align all these standardization activities and to make it industrial successful.
Okay, thank you for your presentation. A question from the audience. Okay. I think you mentioned a very important topic, that means the synchronization or harmonization or discussion between the different SDOs.
Right.
Is that a key topic to get success for 5G for slicing, or is it something which you think will be run by nature?
I think this will be the key factor. It will be a key factor. Because I think for all the people from industrial background, they know how difficult to push one, even in one SDO, like 3GPP. And then 3GPP have a run 2, run 3, SA2, SA3, SA5. And how to align this within 3GPP is already very difficult. But in order to make this solution end-to-end and make this solution works for the vertical, all these standardization activities should work together. But which part or which SDO should be responsible for this alignment, I think this is one of the biggest questions we have now.
Okay, thank you. Now, Hanun, it's up to you to present your thoughts to the audience. Thank you. Where's the button? This one.
Yeah, that one is. The page down is here. Good. All right. So at this point, I guess everybody here is now most convinced that slicing is one of the most important, if not the most important, tool in the tool set of reaching 5G networks. Maybe even more interesting than radio itself. Just to reiterate the motivations behind network slicing. Multi-tenancy is perhaps the most important thing, sharing the infrastructure and sites among the multiple tenants, and there the motivation, why this is so important is that it provides this possibility of new type of services and business models, and of course cost reduction. Operators' investments to the network, 5G network, will be huge, and thus sharing the infrastructure by multiple players, there happens cost, risk reduction as you are sharing the costs among the number of players. Secondly, and related to this multi-tenancy, this is a tool to reach the needs of vertical markets. We can create dedicated architectures, resources, and specialized treatment for vertical needs, which are very divergent from each other. And finally, operator can use it slicing concept for service optimization for his own purposes. It's kind of quality of service in that sense. Regarding the newness of slicing, the new aspect here is that it's transforming the operator business model from connectivity more to selling full networks to the services. Slicing concept itself is quite old. It's more than a decade, maybe 15 years old, maybe 20 years old. First presented in the academic community in Planet Lab and Gini activity. But what has happened since then, during these decades, let's say past 5 years, is the softwareization. We are able to virtualize most of the network functions, and that gives a spin and possibility to create these slices in a more efficient way and in more realistic environments. We can slice LTE networks. That's done. One can say that, okay, VPNs are slices already. One can say that LTE networks are sliced by virtualizing the EPC network components. But in LTE, in comparison to what's baking in the 5G standardization, the granularity of these network functions are the classical network element level, and also the slice selection is on the level of network. So the granularity is highly different between these two approaches. And secondly, regarding the software update possibility, and this relates to the granularity, is that 5G networks are cloud native and they follow this DevOps approach, whereas in LTE, if you update one component, there is a huge dependency between the neighboring components, and very easily you have to update the whole EPC. Furthermore, slicing in 5G has support of native slice selection in comparison to selecting just a single network, and it brings the slicing to the run environment. There's a run sharing possibility in LTE, but here we are talking about, again, more flexible, more finer granularity. And also the last point here is that in 5G networks we are providing new types of network exposure so that these verticals and third parties can leverage information that's collected from the network. One can even exaggerate this a bit and saying that this information what operators are collecting and reselling to the verticals might be more important than the bits what they are carrying. So how does slicing concept then influence the architecture? The key points here listed is how do we manage and orchestrate these slices? Network slices are end-to-end concepts, and it passes multiple domains that creates its own requirements to the management system and orchestrator. How do we compose these network slices out from vertical and physical functions? How do we service chain? What is the role of microservices? And remember, verticals will have their own functions introduced in their own sliced networks. So that's part of the composition. Thirdly, how does end-user equipment connect to these multiple slices and networks? We have this slice selection solution works in 3GPP, but the question that appeared already in the previous presentations and discussions was that can mobile devices offer resources for slices? And finally, there are functional implications to the 5G architecture. To the core network is a bit more easier because of the virtualization, but also to the run. And what is there new, which is stemming from the slicing concept, is that there are common components between the slices and dedicated components inside the slices. So this needs to be reflected in the architecture, in the user plane, in the control plane, as well as in the management plane. Multi-tenancy slicing leads very easily to management recursion in the control and management. The diagram there, the block diagram there on the right-hand side is taken from 3GPP. Here you can see communication service management functions, network slicing management functions, and then below we have network slice subnetwork management functions. Each of these management functions can reside in different domains. And there might be a business interface and business requirements, or SLAs, between each of these management functions. And each of them, they have a possibility to configure and optimize their piece of this slice service, which is provided. Key question is, unsolved key question, which is under debate, is that how much control the physical network operator is exposing up to the verticals. This most probably depends on the business agreements and the SLAs. Also, there are new aspects stemming from this notion of slicing and the management of it, brokering across multiple domains and between the tenants, relationship of slicing the wide area infrastructure, which might not be providing more than the connectivity. And finally, perhaps most interestingly, automated VNF instantiation and self-discovery functions. Slicing has been addressed in a number of EU projects. This diagram is taken from 5G Norma architecture, which has extensively studied the impact of network slicing to the end-to-end networking. And this diagram here shows a core network with two mobile network operators. And as I said, the core network part we can kind of manage with the cloudification and virtualization. But then what happens in the run, there are a couple of options. In the first option here, the run slicing reaches down to the physical layer, and there is a separate slice-specific run stack for each of the slices and each of these tenants. In the middle approach, the common layer stops at the multiplexing layer, so that the slice-specific features end up at the PDCP layer and RLC layer. And finally, then on the right-hand side, we have the run sharing, which is already offered today. This is also coming from the same project, and here the emphasis is this interslice and tenant orchestration across the multiple domains. So we have this ETSI Mano structure. On top of that, we then need to create more logic, more functionality to manage the services and this inter-domain slice behavior. Here are some of the questions that to be considered. Cost of isolation. Slicing is not free, and this relates to one of the questions that frequent question that we have heard today is how many slice tenant is supporting, and the operator, is it tens or millions? I'm inclined to tens, and because of the overhead of management and monitoring, security, etc., it cannot be indefinite. How transparent are network slicing? Question is how much there is a role of mobile devices. There can mobile device go and configure this slice, for instance. But monitoring of these slices can end user be part of that. And then granularity of slice selection. And quite interestingly, there's a strong relationship also to regulation regarding networks sharing and the complicated matter of network neutrality. Business issues, they are in the verticals, as I mentioned, that there are huge risks there stemming from 3.9 trillion to 11.1 trillion according to McKinsey. Maybe this is the concluding slides related to these business models. The connectivity, tariffing and packaging, the traditional operator business remains. We have, on top of, we have slicing. We dedicate this bulk connectivity, give new attributes, new functionality, and then this information analytics, information collection provides these new opportunities for self-organization, for analysis, And as I said, perhaps this creates the bits that are more important than the bits that are transferred.
Okay, Hanno, thank you for the good presentation. If I have a short question for you.
Sure.
If no, is no question in the panel. Okay, here's a panel. It's a short distance.
Thanks for the nice presentation, Hanu.
Thank you.
Just one comment about RAN slicing. Probably this is a bit of in the future, but core slicing could make sense. But then I ask myself a question. I mean, there are already concepts like D core, dedicated core, and then
Yes,
ED
yeah.
core. The operators are not even leveraging that concept. So how could you imagine operators jumping into another thing, which is network slicing? Because dedicated core is something, it can address some of the concerns which you were mentioning. For example, service identification, meeting the need of the verticals. So why would an operator use network slicing? And also, just to let you know about this fact, I mean, we already have about 9 QCI classes in LTE. I mean, the operators hardly use 2 or 3 of them. So
Yeah, yes,
we
yeah.
already have so many functionalities which we don't use, and then yet we come up with another thing. So this is just what would be convincing for the operators for slicing?
Okay, good question. It is the multi-tenancy. What most probably is the justification for the slicing. The current network construction, LTE, as I said, the granularity is on the network level. There are not that many operators globally that it affords that type of sharing. We have MVNOs, sure we have. But due to softwareization, virtualization, and reaching these verticals, we think we are able to create efficient infrastructure sharing and dedicated networks. In that case, we need better selection mechanisms than what you mentioned, this D core and ED core. That was one thing. Regarding this quality of service type, slicing is more than quality of service because it gives us possibility to package also computing. So, and again, the need for quality of service were coming, or the unneed of quality of service was limited by the capabilities of LTE. In 5G, we are talking about low latency. Latency is below millisecond or 10 milliseconds. That type of quality of service requirements hardly are going to be offered to everybody because you don't need that. So the separation of quality of service is happening because of the capabilities what the radio and the network is going to offer. Otherwise, we'll lose that edge.
Okay, thank you, Hanno, for this good feedback. Okay, according to time, I think I'd like to conclude the session. It was, at first I have to thank you to my great panelists. Give a good applause. And I hope you got a better understanding what 5G and slicing is in the future. For the time, it's a little bit foggy. I agree that, but it I hope it gives you a couple of insights what we are discussing and what is important for us for the 5G community, which we have to take care about. It's not RAN only. It is not only core. It is everything which is a part of the 5G technology. And I think you as a research group, you are a big success factor to make 5G really bring it to reality. And have in your mind, that is my wish from operations, because I said that already, please have in mind that you're creating a complex vehicle which should be maintained in the future. To make it operable, make it simple as it is, as it could be, not complex. Simplicity is a key request from an operator point of view. Having said that, thank you for your attention. Thank you for being here. And now I would like to hand over to the closing panel because this guy is pushing me. Thank you for that.
Session of EuCNC 2017, and we are starting here a new tradition, and the tradition is that we have a conference flag, and from now on this flag will be passed on to the next organizer. So I'm giving this flag to Matti, which is this year's organizer. And Matti will pass on the flag to Miha and Moitza, which are the organizers of next year. So thank you, Matti, for an excellent organization, and good luck for Miha and Moitza.
This is not the national flag, so it doesn't matter if it touches the ground.
Very formal.
Thanks for you've set very high standards. Thanks for everything this year. We will try to step in your shoes. We will try to match the standards that you've set. Perhaps even cross them a little bit, but it's going to be challenging, of course. Thanks for everything, and yeah, please thank Matti, I think, one more time for excellent organization. We will try to keep up.
Miha, I wish you all the good luck.
Thank you. Luis already explained me what the definition of good luck is, so I will keep that in mind, Luis. Thanks.
Okay. Good afternoon, everybody. Hopefully you've saw us on and off the stage in the past day. So my name is Moitza Vok. I'm from the University of Ljubljana. And this is my colleague Miha.
Miha Mohorčić from Josef Stefan Institute, and we are the TPC chairs for the next year edition.
So it is our pleasure today, first of all, to be here on this excellent location and at this excellently organized event. And it is our honor to invite you all to the next year's edition, 2018, that's going to be in Ljubljana, Slovenia. So I'll just try to show a video. Hopefully I will be successful in that. Because they say that, okay, obviously it will not run today. So what I wanted to show you, but unfortunately I will only stick to the pictures today, is the venue. So for those of you who might wonder where Slovenia is, it's in the heart of Europe, it's on the sunny side of Alps, and it's at the tip of the Mediterranean. It's very beautiful, it's warm, it's welcoming in June, so we are very happy to have nice dates for next year, same as here, I guess. It's also a very green country, a very safe country, and very pleasant to live in. You can call me a little bit biased, but I challenge you all to come and see that there's some truth in what I'm saying. We will be hosting the event in the capital, Ljubljana. That's a dragon city. It's a mascot of the city. It's a small country, a small capital. It's everything in boutique edition, I would say. It was proclaimed as the green capital of Europe in 2016, and as I said, it is welcoming, and it's going to be very fun to host you there next year. And before I show some more of the nice landscapes, I'll give my word over to Micha to tell you a little bit more what's going to be the topic of the next year's edition.
Yes, thanks, Moitza. So EuCNC 2018 will be again, you will say again, about 5G, but of course there's a lot of work still to be done. Of course, now with the ending of phase 1 5G PPP projects, the emphasis will slowly, or actually quite quickly, go from the core technologies more and more towards the verticals. We've heard a lot of that already in Oulu this year. I believe we will hear more of that next year. Also a lot of new research and development results, tests, and of course we'll be 1 year closer to the commercial deployments. So with all these additional tests, we hope to have as strong the demonstration and exhibition part as it was here in Oulu. It's actually something that is growing from one to another EuCNC conference. And I think that is one main thing that makes this conference different from other conferences in our area. So, of course, you've already perhaps seen the announcement for the next year in the materials. It's in the final program. The structure of the conference is going to be pretty much similar as this year. So we have the track chairs. The tracks are pretty much confirmed. Track chairs have all been confirmed. All the other people who will be helping in organizing and running the conference before it even starts, so actually collecting papers, assigning reviewers. Probably many of you will be also invited to be reviewers, so that is now pretty much underway. We have pretty much similar key dates as you're used to from previous years. So roughly in February is deadline for submissions. Roughly in April you will be notified about the accepted papers, and the draft final program available somewhere mid-May, hopefully. And of course, as you've seen before, 18th to 21st of June, we see each other in Ljubljana. The tracks, you can see it's 6 main tracks. They're pretty much similar or almost the same as already this year here in Oulu. As mentioned before, with this shift towards the verticals, probably we can also anticipate a little bit of shift of contributions from where we had most contributions this year, that was in physical and radio access. We hope to have also more contributions next year in application areas and services.
Okay, thank you, Micha. So as said, it's going to be only photos today. Check out the website for very nice movies. And there's not much for me left to say, except that Slovenia is the only country in the world that has love in its name. And we would love to welcome you next year at the 2018 edition. Thank you.
Welcome, everybody.
Could you place the... Cannot find the click. It's better with mouse.
Is there? The mouse is crazy.
sometimes mouse is very useful.
Yeah.
But it's not that.
Oh.
Not that.
Which one? This one?
This one. Okay, good afternoon, everybody. I am the second speaker for this closing session. I will try not to be too long. And I was asked to give you at this end of a conference, the nice EuCNC conference, an update on the 5G PPP collaboration and moving ahead. Don't be afraid, this is not a gas factory. This is the 5G PPP governance, let's say, scheme. Let's remind that the 5G PPP is a 7-year partnership leading to the introduction of 5G infrastructure and the rollout of 5G services in Europe from 2020. The public-private partnership was created by a contractual agreement between the European ICT industry, represented by the 5G Infrastructure Association, and the European Commission, signed in 2014. So you see in this scheme, let's say, the three main domains, 5GIA, European Commission, their partnership board, and all the work groups, policy work groups of the 5GIA, the technology work groups of the 5G PPP initiative with the projects and the steering board and technical board. And all this world has to coordinate, but it's not so difficult. So this chart shows you the ongoing 19 projects of phase 1. And you can see in this area a nice booth of our projects, of some of our projects, covering all domains of 5G developments, whether it be radio, whether it be frontal, whether it be hardware, SDN virtualization, or security. Now it's an important time in Oulu this week because we have just had 2 sessions launching the phase 2, the 23 phase 2 projects, and making a point on the phase 1 results projects. And as you can see in this time plan of the 19 phase 1 projects, still many of them are ongoing, at least until the end of this year, if not the middle of next year. Some of them also are finishing by the end of this month, but they will continue to work with us, at least in our work groups. My colleague Bernard Barani will speak just later of the results, learnings of phase 2 call. I will just say that a strong continuity sign is that 8 out of the phase 1 projects are continuing throughout phase 2 with other names, other targets, but on the basis, which is a good sign of synergy. And you can see rapidly the phase 2 time plan. We've just had 2 sessions here at Oulu with nice presentations, short but nice presentations from the phase 2 projects, covering all these aspects. And you can see that in terms of time frame, they are beginning now, as of June, and will finish for most of them around November 2019, if not for certain other ones in mid-2020. So I will not insist on the selection learnings of phase 2, which will be detailed by Bernard. What we can say is that they have a very good, they present a very good coverage of the work program as defined by the 5G Infrastructure Association pre-structuring model, defining targeted domain, targeted areas, targeted actions, the TAs. They have also, for most of them, declared in their presentation and candidatures willingness to collaborate in the working groups, technology, policy work group activities of the 5GIA, the 5G PPP, which is a very good sign of synergy and continuity. And we will see that in terms of verticals, in terms of domains, in terms of readiness for 5G trials, in terms of SME presence, it's very positive results and positive learnings we have with these work groups. Just to remind that the 5G PPP, as I said, is a 7 years adventure. And in this adventure, our contractual agreement has defined key performance indicators, KPIs, in 3 main domains, high-level domains, business-related KPIs, such as the leverage effect of EU research investment in R&D, compared with public funding, the SME participation, the market share of 5G equipment in Europe, the more technical KPIs, performance in terms of security, in terms of deployments, in terms of throughput, in terms of reduction time to deliver, and also societal KPIs that are perhaps the most ambitious, with the privacy, security, with the challenge of energy consumption, with a drastic reduction of 90% compared with 2010 energy at the end of the PPP, competitive offer for 5G systems, high societal value new services, and certainly UHD TV and M2M will be overpassed by new defined services. And also the availability of 5G skills throughout Europe, organizing with our institutions, research centers and universities, 5G courses and 5G skillnesses in the community. But we can say that we are on track on this objective. Let's not hide the difficulty, nevertheless, for with the phase 3, something like between 60 and 70 projects to target, to converge on these high-level KPIs. So this will not be an easy task, but we have all the resources to do that. The 5GIA and 5G PPP have, for that, aside the projects, have launched work groups, policy work groups by the association, like pre-standards, vision, SME, spectrum. You had, for instance, a workshop and a panel with Thierry Etielta of spectrum messages from the association. We had also in technology, in technical workshop, work groups, architecture, security, we had many also workshops, including colleagues, security notably. And all these results of the 5G PPP works and mainly white papers are visible on the 5G PPP website. And the last one being the white paper we disclosed in Barcelona, the 5G innovations for new business opportunities, and also recently disclosed the security landscape, the SDN NFV, and the network management. The architecture one will be shortly updated. So I invite you to see there. Just an emphasis on the content of the last white paper, 5G innovations for new business opportunities, where not less than 11 projects have contributed to this white paper. And to illustrate the results on the ITU technical KPIs, ITU targets that we have reached. And one of our cross 5G PPP workshops held in Athens in February revealed some quite interesting results in terms of technical KPIs such as throughput, latency, density, high-speed mobility, and energy efficiency, where nearly all these KPIs compared with the ITU, let's say, thresholds are reached. Just the high-speed mobility on highways is not reached. This shows that definitely, it was said here at the conference, this topic of mobility, and particularly high-speed mobility, is certainly one of the coming challenges to be met. Then 5G PPP, with all those teams, projects, work group, and so on, is leading innovations toward 5G, and thousands of researchers and developers across Europe are working on those innovative solutions. It's the reason why it has been said last year at the Mobile World Congress that 5G PPP was the biggest worldwide research investment effort in the world. So we have to transform, as we say in rugby, transformer l'essai and make that very nice results. Working on solutions for the definition of 5G architecture, of a flexible RAN, new spectrum opportunities, frontal backhaul solutions, virtualized networks, and so on. Results and demos of all these aspects are extensively reported in publications and event presentations, such as in the booth at EuCNC there, in order to disseminate valuable findings and strengthen Europe's impact through 5G developments. So we will publish shortly what we call the golden nuggets of phase 1 projects, the most highlight results from the projects that could be covered in 4 main domains: 5G system design and evaluation aspects, 5G air interface innovations, network management and security innovations, virtualization and service deployment innovations. And the technical board of the 5G initiative has worked hard for leveraging these and a synthesis of all these results. So you will have nextly the production of this document. Definitely, projects are building pre-standards consensus among their partners and provide relevant contributions to standardization, to 3GPP, to ITU, to ETSI, in order to strengthen Europe's influence. And these initiatives are shared within the global 5G research community in order to avoid fragmentation of standards and deployed technologies. So you have here just a representation of our 15 golden nuggets that will be presented in this next paper, and that you can see in the booth demos. So phase 1 projects can be very glad of their results. 5G Pan-European Trials Roadmap is another important story coordinated by the 5G Infrastructure Association with other. It's an open work group led by our colleague Didier Bourse, and it's quite an open group building on the basis of the production of the 5G manifesto last July by the industry in Brussels, and of the 5G action plan of the European Commission produced in September. So we have defined 4 pillars for this trials roadmap strategy. First one, building Europe 5G readiness through 5G private trials done on bilateral, multilateral basis between operators, vendors, verticals, and other stakeholders. 5G for vertical industries, vertical pilots. So the selection of these vertical pilots should notably take into account the sectors of the 5G manifesto and also what we have already addressed on the 5G use cases, such as connected cars, for instance. Then the UFA Euro 2020, that will take place in June 2020, has been chosen as the launch event for 5G in Europe, gathering 13 cities in European Union with nice 5G demos that could be shown there, such as augmented reality, virtual reality, automated transportation, and so on. And trial cities, in complement of the UFA 2020, there will be also a 5G City Challenge that will be organized in Europe for trialing 5G in Europe. So this scheme I will not detail, but this represents the building blocks of the trial roadmap strategy with the private trials, with the events, the UFA, and with the platform being the tools, 5G platforms for private and for verticals, pilots. This also will be in conjunction with our international partners. For instance, there are, let's say, discussions that China-EU could be a good starting point for trials. So this has to be discussed. And of course, as it was said in the manifesto, that European Union, member states, regulators should facilitate these investments in fields such as spectrum, regulation, net neutrality, and others. So 5G PPP supports international cooperation towards consensus building. Definitely, this innovation will be achieved through international cooperation with other regions of the world, such as China, Japan, South Korea, North America and Brazil, with whom we have signed MOUs, and India will come certainly as a next partner. So the last messages of this presentation will be: let's go towards a smooth but committed 5G roadmap. Let's avoid fragmentation. Let's respect all the standardization steps toward full 5G globally harmonized standard. As said the chairman of team at our 5G global event in Rome last year, short-term solutions will not solve long-term issues. And let's avoid premature 5G launch announcements, since now 5G is the brand defined by 3GPP for this technology. Of course, let's not use the word 5G for anything, and I will not quote anybody. But be quick, let's be quick, business-oriented and cooperative with the trials, with the verticals, with boosting the standardization process, as it was done with the NSA implementation of the new radio that has been advanced by 6 months by the end of this year instead of mid-2018 by the 3GPP. This is a good example. And push collaborative international research, of course. And just to finish, more than other regions in the world, Europe's vision for 5G, and I think it's totally shared by the European Commission, is very ambitious, aiming at a deep transformation, industrial and economic transformation. It's not only the 4G++. 5G will be a full connectivity platform and not only an improved air interface, even aggregated with other technologies. Let's implement our phase 2 projects, prepare phase 3 towards 5G deployment and 5G evolution. I speak voluntarily of 5G evolution and not 6G, 7G, and so on. And I just take one of the good words of this conference by my colleague Colin Wilcox, chair of the board of the 5G Infrastructure Association, yesterday. 5G is a hype and 6G is a fantasy. So let's transform the hype in reality. If we speak of 6G, this will mean that 5G will have failed, and of course we will not fail, 5G will not fail. We will speak of 6G perhaps in 2030. Just to finish a figure, IHS market consulting company in London in March has foreseen the figure of 12.3 trillion of US dollars as the impact of 5G to the world economy by 2035, which is huge. All sectors benefiting from that: automotive, health, finance, telecoms. So more than 12,000 billions of USD for 2035. That's a nice perspective. Let's keep this figure in mind, and thank you. Thank you to all. If there is no question, I let the floor to Bernard. Alors, il faut que le
spécialiste du switch over.
Yeah, the mouse.
I mean, too many people fiddling with this device. You go for escape. So your presentation has blocked the system, Jean-Pierre. So this is the malware presentation.
The mouse is freeze again.
It's that's like a screen here, so it's somewhere here now, and just scroll to the left.
Oh no. Okay. Which one? This one?
No, this one.
This
BB. Yeah, BB. Why? But it's not on the screen.
Yes.
Ah, yes, comes up. Okay. So thank you very much, and being the last stumbling block between you and the lunch, I will try to get as fast as I can. So time has come now for a few conclusions and try to let you know what is our perspective of the future, let's say, period, as also was already sketched out by Jean-Pierre Bien-Aimé. So first of all, since we are reaching the end of this conference, just to share with you a couple of figures which have been given to us by the organizers and by the program committee. So this year we had more than 600 registered participants, which is in the order of 640, I think, including exhibitors from altogether 32 countries. So that's a huge number by our classical standards. I think it's the best conference we ever had so far in terms of attendance, at least over the last 5-6 years. I don't remember that we ever broke the 600 limit. We have we had about 15% of registered participants outside of the EU, which is good, but potentially something that can be improved. 240 submitted papers, which is about significantly higher than last year, and 25% of the paper, interestingly enough, originated from authors from outside of the EU, and 40 exhibition booths, which is something that, on the Commission side at least, we value very much, because this is also something that gives a certain personality to this conference, contrary to the classical, let's say, IEEE conference like PMRC or ICC, the GlobeCon that you might be more familiar with, where they don't have this kind of booths or presentations. We believe this is something which is a little bit unique of this conference and something which is good. So for us, from our perspective, you may have reached different conclusions from your own experience, of course, but from our perspective, it seems that EuCNC 17 was really a great success and a good international event. And we are, again, very grateful to the organizers for these results. So in terms of the various discussions, it's always difficult to make some short conclusions on the discussions that took place over the last 3 days, because there was really a very rich set of discussions that took place. But we certainly could identify a clear trend towards 5G, let's say, deployment or trials, a test case, and we see it reflected by the number of national or regional initiatives to deploy specific test beds or specific test infrastructures. For instance, the 5G TN here in Finland is one example. We see also, and we hear also from the industrial actors, the key industrial actors, that the industry readiness is progressing fast. We see what's happening in the standards. We see what's happening in the spectrum side. I mean, just look at EU last year. At the same time, we didn't have any position on spectrum. Now, at EU level, it took less than 6 months actually to develop a position on the 5G pioneer band. So this was very fast last year. It took place last year, end of last year, and we have progressed really quite a lot in terms of identifying all these, let's say, framework conditions that will later support the deployment of the technology, be they the standards or be they the spectrum. Of course, a lot remains to be done, but this is moving. On the other hand, if we hear from several voices that there are a lot of initiatives to move the technology to the fields, we hear from Verizon in the US, AT&T, the things, KT in Korea, and so on. We also got the messages, and I wouldn't see this as a conflicting message, but we got the messages that the 5G full promise, that means this overall industrial transformation, is something which is still a little bit away from us. And some of the players, to a certain extent, they seem to regret it, sort of blaming the ecosystem that things are not progressing forward fast forward enough, or maybe not ambitious enough. But this is something that, on the other hand, gives the research activities a full legitimacy and gives us also, I would say, even more responsibility to satisfy the expectations of the operators and the customers that would like to see more radical transformation in the 5G ecosystem compared to the, let's say, maybe evolutionary path, which is at the moment taking place or being implemented at the level of the standardization level, which is maybe something a little bit less radically innovative than the early 5G plans or models would have suggested. So again, conclusion on that, I think we really have an interesting research path ahead of us, especially in the context of all these things that were discussed in the previous panels and again during the conference, in terms of new technologies in the core, slicing in the networks, and applicability of this type of new technologies to the verticals. Here, probably there is still a lot of things to be done and to be validated. Now, EuCNC next year will be in Ljubljana. You heard of it, so I don't expand too much on that. Seems TBD, I put here seems TBD, but the previous speakers from the conference organizer in Ljubljana already sketched a few potential themes. So it's not contradictory to what he said. What I mean is the motto of the conference, which was this year European roadmap, global impact, or something like that, if I remember well, is not yet defined. And we will have on our side to think a little bit with the steering committee if we want also to give to this next edition a little bit more visibility to things that come beyond 5G. We had a few sessions in this conference about terahertz conference, or terahertz frequencies, or terahertz type of communications. We will probably have to think a little bit what is the balance that we give to the various subjects. But from our perspective, from Commission side, it's clear that one of our objectives is to continue to increase the scientific quality of the papers, the international participations, and also to have these things which, again, we try to develop as a unique feature of the conference, which is these clear links between the academic world and the industrial world. It was very sort of encouraging when I heard the previous speech from the Intel speaker, who said, okay, this is a problem we have in industry, and here the academics, this is a nice problem for the academics to solve. So it shows that really this partnership notion is something that we can really together develop. In terms of 5G PPP phase 2, so I close now the chapter on the conference itself. In terms of the 5G PPP phase 2, we had the kickoff of this phase here at this conference. But just to share with you a few results, or the way we see the results. Again, you might have different perception, but our own perception or analysis is that we had as key objectives for this phase 2 to go beyond pure technological, let's say, study and developments, but to move towards more proof of concepts, experiments, and inclusion of the vertical sectors. And we believe that this is a result that we have reasonably well achieved. We have a number of projects which we have now implemented, so the contracts are going have started on the 1st of June for all of them. We have a number of projects which you have heard of, which have been presented. So here you have in blue the pure research project, in black the innovation projects, which are maybe a little bit closer to the market. Blue at the bottom right of the slide are the 2 projects that we implement with the Taiwanese infrastructure providers. And in red are the so-called support actions. We believe that this set of projects gives us a very good basis to, again, continue this program notion and with this collaborative notion that we try to implement across the various projects. We have made a very short analysis to compare what it is that we implement and what did the 5G Infrastructure Association propose in terms of technological areas to be covered. So it's not 100% perfect in terms of coverage, but it covers about 80% of the requirements which had been set by the 5G Infrastructure Associations. There are a few holes. For instance, there is no specific project on millimeter wave type of technologies. Doesn't mean that millimeter wave is not covered. It's covered in very specific projects as side issues, but there is no one specific project as we had the millimeter magic in the past, which is really focusing only on that particular aspect of 5G. Also maybe because at the standardization level and in industry, things are also progressing very fast by themselves on millimeter wave type of technologies, and the research aspects are also moving to other type of domains. But we believe that this kind of matrix presentation is more or less in line with the reality. In terms of stakeholders, so you have a couple of figures which are public. What we like from this phase is that we have managed to increase the level of SME participation to 23%, whilst in the first phase we only had 14% participation of the SMEs. And at the same time, we don't compromise the overall participation of the industry. 5G PPP is an industry-led initiative, which again does not exclude the academics, but it's clearly an industry-led initiative. And altogether, we managed to keep more than 60% industry participation altogether in terms of, let's say, members of the various projects. And another element which is interesting in terms of participants is that if you look at the, let's say, the sociology, I would say, of the participants in phase 1 and the sociology of the participants in phase 2, you will discover that because we have now put this emphasis on the vertical industries and on the potential users of the 5G technology, which has attracted companies we never saw before, like Volvo, PSA, or Wind in the energy domain, or Aeon, or these kind of companies, we have about 64% of the partners in the new projects, which are newcomers. So we really try to expand the 5G notion to the user community and to partners which I wouldn't say they never had heard of 5G before, but which are in discovery mode in the context of 5G, and we see this as a very good direction that the program is taking, and we see this as a very good material to build upon to sort of increase the vertical presence in this business. Because we talked a lot of 3GPP, but I'm not an expert at the 3GPP. Colin, the chairman, is much more expert than I am, the chairman of the 5G Association. But my little experience with 3GPP is the vertical industry is basically absent. I mean, maybe you have one company, Toyota, maybe sometimes they participate, but it's very little. These guys are very little visible in this kind of forums where the international decisions are being taken. So this is our assessment. I will not repeat because it was presented by Jean-Pierre Bien-Aimé already, but again, from our perspective, we have a solid set of activities ahead of us that we can capitalize on to move forward. So now, the very, very last element of this presentation is the phase 3. So what do we do after the phase 2? So again, we had the kickoff at EuCNC, so that's the red arrow here, 14th and 15th of June, so over these last 3 days. Now, what we want to do in phase 3 is again to move towards more demonstrations, trials, larger scale pilot implementations, and at the same time preserving some room for research to prepare for what we call the longer term evolution or 5G LTE. I don't know if this makes sense, but so we try to preserve these two notions, moving towards support of deployments and at the same time planning for future evolution that will take time because every generation has at least 10 years in terms of development cycle. So we will start beginning of next year. We hope first to adopt the work program end of October. So at this moment in time, all this is in discussion with the member states. And we just only yesterday, we submitted to the member states the latest amended version of the work program, which hopefully takes into account the latest set of comments they did address to us. So we have done that. So now the ball is in their camp. If we have this adoption in October, the plan is to have, at the same time, the opening of the first calls and to have the submission of the first proposals end of January, beginning of February. Will depend on the exact date in October when the thing is published, end of October or mid-October. So this will apply to what we call the demonstration trial platform. What we try to do with this activity, which is the blue box at the bottom, phase 3A, we call it verification demo trial platforms, integration radio plus networks. We try to have a platform which is reasonably representative of a 5G end-to-end platforms, which will help us to validate in the first phase, let's say, the KPIs that we have set ourselves from the pure network and from the pure technological perspective. Does not need any vertical to be validated. I mean, if you have KPIs in the domain of spectrum sharing, this is something that you can do irrespective of any application running on top of your network. So this will be an activity for which we have planned for 60 million euros, if my memory is correct, and for which we expect maximum 3 to 4 projects. So it gives you the order of magnitude of the projects that we expect to see here. But at the same time, we expect that these verification platforms can be used for later activities, and this is the yellow box at the top, to help vertical industry to come with their own applications and test the 5G technology against their own vertical requirements. So this is a kind of phased approach where on the one hand, we start to develop a sort of a platform, and on top of it, we plug some vertical use cases. And this call for what we call the trials and experimentation is supposed to, let's say, have a milestone or a deadline for submission of proposals around November 2018. So this will be implemented in 2019. Whilst the first phase, the verification platform, is something which is implemented in 2018 as soon as we can, because we are a little bit late already on this type of things. In addition to that, we have added a block which is called 5G connected cars in EU corridors. So that's a dedicated action we want to initiate with the automotive industry, which has got a budget of 50 million euros, under which we support the implementation of 5G technology to support connected car use cases and to validate or to demonstrate connected cars use cases. And what we call EU corridors is at this moment in time subject of definition with the member states. So we expect, and this is something you have to look at, we expect that the member states will provide us with a number of routes or paths or transnational paths where they say, okay, these are the kind of paths that we would like to consider for this type of European experiment. There is already one corridor which has been implemented, for instance, between France and Germany. It's a Merz-Muckel, I don't remember the name of the German city. But there is one such example that exists already today. But we want to sort of make it a little bit more general to have really demonstration of cross-border type of applications, knowing that cross-border or cross-domain can be one of the issues to solve in the context of connected cars. And at the top, we have this 5G research and innovation for long-term evolution, which was supposed to be, let's say, fueled by about 85 million euros, something like around 90 million euros. I don't remember exactly. And to be implemented in 2019. But because of budget constraints, we have had to cut this budget into two. So the call, which we will launch, submission of proposal end of 2018 to be implemented in 2019, has been only allocated with 44 million euros, knowing that the rest will be provided in 2020, because we don't have enough activities in 2020 to consume the budget, which is our allocation for 2020. So for 2020, we will come up with new activities that will be the tail of this research, long-term research, and a few complementary innovation type of activities to fuel or to support take-up of the technology through SMEs or through innovators. So that's what we plan to do with the next, let's say, work program 2018-20. So far, it has been very well received by member states, so I don't expect any major catastrophe here, so it should be agreed as such. Just a word on international cooperation. We have also planned for several activities with international partners in the context of the joint declaration of cooperation that we signed and the memorandum of understandings that the 5G Infrastructure Association did sign with other regional organizations. So as you can see here, we have planned activities with Japan, Republic of Korea, People Republics of China, Taiwan, United States of America, and Brazil. The Brazilian one will be for 2020, so for the moment it's not exactly well specified. But the idea is really to cooperate more on the application dimension of 5G using infrastructures that the various regions can have available to test advanced applications, either in the millimeter wave domain or in other type of domains. For instance, with China, we have very specific objectives to run trials at 3.5 gigahertz, and in the context of V2X connectivity for a budget of 6 million euros, but we have similar type of approaches with the other regions. So that's the international cooperation facet of the work program. And maybe one thing I did forget to say is that in the context of the 5G action plan, which is something which is, let's say, another type of activity that we are supporting, we expect the trials that we will support through the 5G PPP to make some contributions to the trial roadmap of the 5G action plan. It should not be the main contribution, because we expect that the main contribution has to come from the private actors through investments from the private actors, and it's their business to invest, to make the technology making their way towards deployment. But the trial part of these, let's say, funded actions can be considered as, let's say, seed money or money to oil the machinery, if you want. So one slide that my director presented in his introductory panel is what comes next in terms of framework program. It's a little bit early. It's not too early to talk about it, but just for you to be aware of that, again, as he said, this discussion has started, but one thing you may want to know is that what the Commission is going to do this year, the Commission this year is going to make an impact assessment of the Horizon program. All the budget programs, they are going to be subject of a sort of audit to see what went well, what did not go well. And this will be the basis to develop for next year a kind of Commission proposal, which, as my director said, will have to be there around mid-next year. But this Commission proposal will look into things which are content related. I mean, should we support the telecom sector, or the X sector, or the biomedical sector, or whatever. But it will be also instrument related. And this is where you may want to have some reflection with your member states. Questions such as, Do we continue to support industry? This is one of the questions which is open at this point in time. Will we continue to support industry at the same level as we did so far, or do we need to finance more the academics and the innovators or the startups and these kind of things? That's one of the questions which is on the table. Should we need to continue with grants, or do we need to finance through loans, through equity financing, or through other type of financial mechanisms? This is a question which is open at this moment in time. Shall we continue to implement PPPs, or do we need to move for other type of implementation actions in the context of FP9? Again, another question which is open. So it would be good if you can have your own reflection on these kind of issues and discuss them with your member states, because member states have really a very strong role to play in this exercise. If we want too much to go in one direction, they will be the one to redress us and to move us in the other direction. But these are the kind of questions which can have, again, a very high impact on the way the research ecosystem in Europe is sort of supported. So don't think of it in terms of, oh, I want to support in the future activities for next generation 6G or whatever type of technologies. Think also in terms of how you want, what kind of tools you think are best to support the objectives that you may want to have, which can be different, whether you come from the industry perspective or whether you come from the academic perspective. So almost final slide. Don't forget also that our colleagues from Korea, I couldn't get the slide, but I could get the photograph that was taken in Japan in last May. Our colleagues in Korea, under the leadership of the 5G Forum, they will organize from the 22nd to the 24th of November, the 4th 5G global event, which is organized through by all the regional industry associations, which are having significant initiatives on 5G. So that's something you might be interested in attending. And on our side, hopefully see you next year. And enjoy the lunch. And maybe also one last word, because I fully hand over to Matti, is that I would like to convey my, or our, from Commission side, very high gratitude to all the people who have worked very hard to organize this conference. Matti and the local organizer, for sure. I think they did a great job. All the people from the University of Oulu who have been involved did really a splendid job. Luis Correa from the steering committee and all the people who helped there. And also, I think we can give also a big applause to these key personalities, such as the Minister of Finland and the TKS Directorate General, who sort of honored us with their presence. I think if you can help me to give a big hand to all these people, it would be nice. Thanks. Merci, chef. What do you have to do? The flower.
All right, everything good ends at a time. This is it. Let's go home. Let's eat lunch before going home. Have a nice summer. See you next time. Bye, bye, bye.